Welcome to Understand the Math. In this video, I'm going to teach you how to solve absolute value inequalities. I'll start by teaching you the two types of inequalities that you might be asked to solve, and then we're going to walk through these three example problems so that you'll know exactly how to solve them. Let's start by learning how to solve absolute value inequalities. There are two types of absolute value inequalities. The first type is where you have an absolute value that is less than a constant, and the second type is where you have an absolute value that is greater than a constant. Let's look at the graph on the left and see what our solution is going to look like when our absolute value, y is equal to ax plus b, is less than our constant k. It's going to be less than in this region and in this region. Our solution then is going to be between two numbers. Let's now look at the graph on the right. We have our absolute value graphed in blue, and then again we have our constant k, and this one says that our absolute value is going to be greater than that constant. So that's going to happen in this region and in this region. So the solution is going to have two pieces to it. The first piece, x is less than some number s1, and then we're going to have an or, and then a piece, x is greater than some other number, s2. Just to make things easier, I've written down exactly what you have to do to solve these types of equations. When you have a less than, you're going to solve the inequality that ax plus b is between minus k and k. And when you have a greater than, you're going to solve two inequalities, one where your linear function is less than minus k, and one where it's greater than k. One way that's easy to remember this is when you have a greater, you have an or. Let's now do some example problems. In our first example, we're going to solve two inequalities. The first one, we're going to have a less than, and the second one, we're going to have a greater than. Let's begin with the first one. The first one is going to be absolute value 2x minus 4 is less than 2. When you have a less than, you're going to solve the inequality. Minus 2 is less than 2x minus 4 is less than 2. Now we want to solve for x, so let's get the 2x that's in the middle by itself. To do that, we're going to add 4 to all three pieces. 4 minus 2 on the left is 2, and in the middle we have a 2x, and then on the right we have a 6. Now we want to get x by itself, so we're going to divide each piece by 2, and this gives us 1 is less than x is less than 3. We can write this in interval notation as 1, 3, and we have a parentheses around both 1 and 3 because there is no equal sign at those points. Let's now look over at our graph and see if our solution makes sense. We wanted to find the x values where our absolute value function was less than 2, and that's going to be in this region and in this region. So if we trace down, we can see that this is 0.1 and this is 0.3, and our solution is going to go from 1 to 3. So that makes sense. Let's now look at the second inequality. That inequality is the absolute value 2x minus 4 is greater than 2. Remember, when you have a greater, you're going to have an or, so you're going to have two pieces. The first piece is 2x minus 4 is less than minus 2, or your piece 2x minus 4 is greater than 2. Let's solve the one on the left first. We're going to add 4 to both sides. This gives us a 2x is less than 2. Now we'll divide both sides by 2 to get x by itself, and we have x is less than 1. Let's now go over to the right-hand side and solve that one. To get 2x by itself, we're going to add 4 to both sides. This gives us 2x is greater than 6, and then we'll divide each side by 2, and we get x is greater than 3. Let's now write our answer in interval notation. We have x is less than 1, so that's going to be from minus infinity to 1, parentheses around both, and then the or translates to a union sign, and then we're going to have 3 to infinity. Let's now go up to our graph and let's see if this makes sense. We wanted to find where our absolute value function was greater than 2. So that's going to be in this piece and in this piece. And you can see that it's when x is less than 1 or x is greater than 3. Let's now solve this absolute value inequality. We'll start by writing down our problem. We have absolute value 6 minus 3x is less than or equal to 6. This one has a less than in it, so we're going to have our linear function in the middle, and we write this as minus 6 is less than or equal to 6 minus 3x is less than or equal to 6. Now we want to get the x by itself, so let's subtract 6 from all three pieces. This gives us a minus 12 on the left, is less than or equal to minus 3x in the middle, is less than or equal to 0. Now to get the x by itself, we're going to divide each piece by negative 3. I'm going to put a star here because this next part's super important. When you divide by a negative and you're working with inequalities, you have to change the inequality. So on the left, we're going to get a 4, but instead of a less than or equal, we're going to have a greater than or equal. And then we have x. And then the right-hand inequality also flips, and we have a greater than or equal to 0. I feel like this is always written backwards, so whenever I have something like this where you have a larger number on the left, I like to rewrite it. This is the same thing as saying that 0 is less than or equal to x is less than or equal to 4. And that just is easier to read. In interval notation, we would write this with a closed bracket at 0 and then a closed bracket at 4. Let's go over to our graph now and let's see if this makes sense. We wanted to find where our absolute value was less than or equal to 6. So that's this piece and this piece. And if we trace down, we can see that is at the point 0 and then at the point 4. So our x is any value between 0 and 4. Let's do one more problem. In this example, we have an inequality that has a greater than sign. Let's start by writing down our problem. We have absolute value 4x minus 6 greater than or equal to 2. Now, when we have a greater than, we're going to have an or. So our first piece is 4x minus 6 is less than or equal to minus 2. I think that's the hardest part, is writing that piece down. Or we're going to have a 4x minus 6 is greater than or equal to 2. Let's now work on the left piece. We want to get 4x by itself. So we're going to add 6 to both sides. This gives us 4x is less than or equal to 4. Dividing both sides by 4, we get that x is less than or equal to 1. Now let's work on the right-hand side. We're going to get 4x by itself, so we'll add 6 to both sides. This gives us 4x greater than or equal to 8. Then we divide both sides by 4. We're kind of running out of room here, so let's put it over here. This gives us x is greater than or equal to 2. Now we can write our answer using interval notation. Our first piece is x is less than 1, so that's going to be minus infinity to 1 with a closed bracket at 1. And then the or means that we're going to have a union sign. And then x is greater than or equal to 2, so we're going to have a closed bracket at 2 and go to infinity. Now let's look at our graph and see if this makes sense. Our absolute value function needed to be greater than or equal to 2, so that's going to happen here, and it's going to happen here. Now, if we trace down, we're going to hit the point 1, and then we're going to hit the point, well, it's already marked there, but we'll go ahead and write a 2 anyway. So our solution for x is going to be any number less than or equal to 1 and any number greater than or equal to 2. I hope that you now feel more comfortable solving absolute value inequalities. Remember, if you have a less than, you're going to solve an inequality that has 3 parts to it, and the linear function is in the middle. And then if you have a greater than, you're going to have 2 different inequalities, and they're going to be connected by the word or.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.